SDVoE is the matrix transformed, providing matrix switch performance using Ethernet. However, it doesn't stop at matching the capabilities of the matrix switch. One outstanding benefit with SDVoE is the ability to offer multi-view composition on a single display, a claim that the matrix switch simply cannot make. This course explains the multi-view application in more detail and will help you to design your network correctly to ensure you have enough bandwidth for it to function. The SDVoE Multiview feature allows you to apply multiple streams of video to a single display and is widely used for a number of specific use cases within Pro AV, where multiple streams have to be shown at any one time. Historically, in order to make this happen, separate multi-view hardware had to be installed at each display, which required multi-view. This made the design more complex and it was expensive to implement. Very expensive. With SDVoE, you get the option of multi-view on all of your TVs automatically. Design is simpler, capability of the system is higher, and it's cheaper too. Thanks to multi-view being a standard SDVoE feature, no extra equipment is needed and control of it is managed by the SDVoE API. Even if your client didn't have an immediate requirement for multi-view, the option will always be there. And with no extra hardware required to make it happen, there's a far better chance of a future upgrade. So how does it work? To begin with, let's look at multi-view on a display. Here we can see a single display showing one main image with multiple secondary streams being shown in an L-shaped format around the screen. If we imagine the screen is split into 9 sections, we can assign a single image across a number of sections. So, in the case of our L-wrap, the main image would take up 4/9 of the display, and the remaining images would each take up 1/9. The multi-view layout options are provided by the manufacturer's control software, so it's always worth checking with the manufacturer to find out which multi-view compositing options are available. As you can imagine, the layout options for multi-view are endless, so you'll most likely find the vendor will give you a list of predefined layouts to choose from, rather than allow you to choose whichever layout you want. And there are 2 key reasons for this. The first is simplicity, and the second is bandwidth. Bandwidth management is paramount with multi-view. Remember, you're sending multiple video streams across a single network connection. The API needs to calculate how each stream needs to be scaled before it is sent. Each transmitter is capable of sending 2 video streams simultaneously, and only one of these streams can be scaled down. How that stream is scaled is determined by the controller. So for example, in the case of a 2x2 multi-view, if each image was originally a 4K stream, then the controller would tell the transmitter to send a scaled down stream of 1080 to the receiver, while keeping the original 4K stream to make it available for any other display which requests it. In a scenario where images are not overlapping, the bandwidth will never be exceeded, because the multi-view display will only receive the resolution it can handle regardless of how many separate images it's receiving. However, if picture-in-picture is required, where images do overlap, then the API would need to be managed very carefully by the manufacturer's control software, because this would very quickly lead to bandwidth violation. This is a key reason why the manufacturer should only offer multi-view options which are within the bandwidth capabilities of the network. So always check which multi-view compositing options are available if you are deploying a system which requires multi-view.